And then people with type 1 diabetes are more likely to get other autoimmune disorders as well. So there's a genetic susceptibility. There's something that initiates it, may or may not go ahead and start becoming autoimmune, in which case their own lymphocytes are killing healthy cells. They may go into remission, or they may just go ahead and develop diabetes and be diabetic. As a result, glucose cannot go into the cells. This is from your book, but I wanted to go into more explanation. Of course I did. This is from another book in which I can do stepwise edits, so I can lecture and then say, okay, and then this happens, and then this happens. You have the full thing. You have the full chart. All right, you eat a meal. I don't know, turkey sandwich and a cookie. So fatty acids go up, glucose goes up, amino acids go up. And this is when insulin will be secreted in you and me, but a type 1 diabetic has no insulin being secreted. Now, what happens? All right, step by step. First of all, there are no amino acids. They're not being taken up by the cells. And the cells think they're starving. And so they start breaking down muscle to release amino acids into the blood that they can be used for ATP. You remember this from chapter 5. So we're linking this back to chapter 5, how this happens. Their muscle tissue goes away. All right, fatty acids are rising. Cells think they're starving, so fats are being broken down. When fats are broken down, fatty acids go up. We start producing ATP. We produce way too much ATP, and so the liver starts converting fatty acids into ketones. In the meantime, their fat stores are shrinking. All right, now picture we'll say 5-year-old, 7-year-old, picture a child. So this child is now getting increasingly skinny. Even though, I'll talk about this in a second, they're eating more, but they're getting increasingly skinny. So that's our stereotype. All right, the liver says, ooh, crap, fatty acids are up, amino acids are up, glucose is up, person must be starving. Let's get more glucose out there so they'll stop starving. So the liver does glycogenolysis, starts breaking down the glycogen stores, starts converting fatty acids and amino acids into glucose so that we can increase the amount of glucose in the blood, gluconeogenesis. So now, if it wasn't already, there is a high blood glucose, and the liver is contributing to it. Glucagon levels have gone up too, by the way. So now we're trying to get more glucose in the blood because body thinks it's starving. Brain sees all of this, hypothalamus, and says, whoa, crap, we're starving. And so makes that child hungry. Polyphagia means they eat more. So now we have our little skinny kid who is pounding food but still getting smaller. All right, high blood sugar. Now, we had lab 5, that heck of a lab, with all those little bags you were weighing. The reason for that was this moment. When glucose goes up in the blood, where does water go? Into the blood. It comes out of the cells, it goes into the blood. So the cells begin to shrink, and the osmolality of the blood is going up because of the glucose in the blood. The hypothalamus osmoreceptors shrink, and so they start making the child thirsty, and they're putting out ADH to try to pull water back out of the kidneys. Meantime, glucose is winding up in the urine. Now, we haven't talked yet about how the kidney works, but basically, the way the kidney works is it pulls all the liquid part out, leaves the cells in the blood, dumps it all into the tubes, and then pulls back everything it wants to keep. And it keeps about 65–85% of everything that goes into the tubes. It pulls back 100% of the glucose. That's normal. Those are glucose transporters. They're proteins. Do you remember saturation? So there's so much glucose in the blood. There's so much glucose in the urine. And so the glucose transporters are working overtime to try to get all that glucose to come back. And they can't get all the glucose to come back. And glucose winds up staying in the urine. And water is going with it. Now let's make this one clear. Glucose is the food of the brain. The kidneys are not trying to get rid of glucose. This is not homeostatic. We are not dumping glucose because the blood glucose is high. That's not the reason why glucose is in urine. The kidney transporters are not prepared for a glucose level this high. And so they cannot pull the glucose back. It's like, oh, no, So we're losing brain food. Kidney doesn't like it. I make that emphasis because in that worksheet, there will be some students who've written that the kidneys are trying to get rid of glucose. And they're not, because glucose is too important to the brain. But water is going with it. So that causes polyuria. Polyuria means we pee all the time. So now we have our skinny kid who's eating all the time, who's now peeing all the time. And if that child was potty trained, was able to sleep through the night, they're now bedwetting. And even if they're potty trained, they're probably gonna start wetting their pants because they're producing so much urine. All right, then what's gonna happen? Blood volume's gonna go down. Blood pressure's gonna go down. I already told you about the hypothalamus sees that increase in blood osmolality, starts making that child thirsty. Polydipsia. So now the child is drinking all the time, like cannot get enough water. Of course, they're peeing all the time, so that makes sense. All right, blood pressure is going down. Sympathetic nervous system kicks on, which increases the heart rate and shunts the blood from the tissues to the internal organs to try to save the brain. So what happens to the tissues? Well, they don't have oxygen. In the absence of oxygen, how do cells get ATP? Anaerobic metabolism. And what's the byproduct of anaerobic metabolism? Lactic acid. Now then, lactic acid along with, butyric acid, acetoacetic acid, the things that make up the ketones. The ketones are acids. The ketone bodies are acids. So we have high ketones, high lactic acid, pH drops. That's called metabolic acidosis, when the pH drops. We talked about that with lab 2. This is a specific kind of metabolic acidosis. It's still metabolic acidosis, but acidosis is what this poor child is in now, though a large portion of it is because of the ketones. So now it's called ketoacidosis. That's the cause of most of the metabolic acidosis. And you come into work, you see what your patient, and you'll see this DKA, which means diabetic ketoacidosis. You can have other reasons to have ketoacidosis. It's not just diabetic. That's why it gets the D in the front. Specifically diabetic ketoacidosis. Now, what you've not learned yet, big problem, when pH goes down, potassium goes up. What happens to the heart and the neurons when the potassium goes up? Remember that from, where was that? Oh, that was chapter 6.
It can't maintain the rhythm.
It can't because, yeah, remember that the membrane potential goes up. Membrane potential goes up to 0 because all that potassium is going into the cell. It's making a negative cell go up. So now this elevated potassium is going to stop neural function, and it's going to stop heart function, there, which is the final spiral. Now, right before these things happen, the drop in pH is going to induce increased respiratory rate. Because if you remember this, I wrote it back then, and I'm going to start writing it a lot more now as we continue on in our semester to No, that should be free. H2CO3. There we go. All right, acids are going up, which gets detected by the medulla as carbon dioxide levels go up. Therefore, respiratory rate goes up. The effort is to try to decrease carbon dioxide in the hopes of increasing pH. Because if we decrease carbon dioxide, we decrease hydrogen ions, we increase pH. So now let's look at our stereotype. Here's our skinny kid who's eating all the time, peeing all the time, thirsty. Now is getting weak, dizzy because of drop in blood pressure, perhaps cold around the edges because blood's been shunted. Now they're in metabolic acidosis, so now they're breathing fast and deep. It's called Kussmaul's respirations, in fact, named after a physician who noticed that right before the diabetic kid died, they were breathing fast and deep. And then they go ahead and go into a coma and they die. Untreated, of course. So this is our spiral. This is homework 10. Here is homework 10, where you describe back to me this acute pathophysiology of type 1 diabetes, which helps you understand that whole, look at how many topics we just covered that we've already covered before. Now we're kind of pulling that together along with understanding what is it that insulin is doing. And then when glucose levels rise, the chaos that goes on in the body as a result. This is also the essay question for test 5. There we go. I'm going to get a lot of use out of this.
Have you heard of that zone diet?
The zone diet.
Yeah. A lot of people in our state use it. It's to keep the insulin balanced. And that's,
Okay.
I was just wondering if you ever heard of it.
No. No. I mean, that's what homeostasis is. It keeps the insulin balanced. You know,
Like
so.
you get up, you take in a certain amount of carbs, protein,
Mhm.
fats each meal.
Which would keep your insulin level at a steady
Yeah.
state. Because it is the rise of insulin that's going to induce type 2 diabetes.
So basically, it's just eating healthy.
It's just eating healthy.
Yeah.
And then somebody's getting money off of the book.
Yeah.
The royalties. Okay, questions about any of that? Let's see, did I have other comments? All we need to do is give that child insulin injections. And it stops that whole spiral. You will still see it. You will certainly see ketoacidosis because children with type 1 diabetes go on to be teenagers. What do teenagers do?
Rebel.
They rebel. Yes, they do. So
The prefrontal cortex isn't fully developed.
exactly, it's not, and they're very subject to peer pressure, and they want to have pizza and Coke and chocolate along with their peers, and they don't want to appear sick, and they don't want to be doing syringes because they're going to be made fun of, and so they're going to let their blood glucose get out of hand. Plus, typically, a lot of these children are what's called brittle diabetics, that their blood sugar is really liable. It's up and down all the time, and so they're having to really pay attention. Constant blood sugar monitoring. That's where the insulin pump comes in handy with just little tiny injections of insulin frequently instead of the 2 or 3 times a day that someone's going to do with the syringe. And you're not going to get very much of it in the state of Oklahoma, but you will. There are some religions that do not believe in medical intervention. They believe in prayer only. So the type 1 diabetic child is going to go ahead and die. Oops. That was a non-believer kind of statement, wasn't it? Sorry, hope that I didn't offend. But without insulin or God intervention with healing the child, then the child's going to die. The parents are going to be arrested for child endangerment, neglect. So you see that from time to time in the small towns in Oklahoma. There are religions that do not believe in medical intervention, they believe only in prayer.